Hi, everybody. Thank you so much for being here. My name is Emily Jordeo. I'm an environmental planner and GIS analyst with Jacobs Engineering. I'd like to start my presentation by telling you a story. This is a story of Mr. Melanson. He is a resident born and raised in Leeville, Louisiana. Mr. Melanson goes out every day, catches fishes and bait, and sells the product of his work at the store that him and his wife own in town. This is how they get the majority of their income. People like Mr. Melanson all around Louisiana are facing big challenges. The landscape surrounding their communities are changing rapidly every day. Leeville and all these towns are slowly disappearing. They're losing land to hurricanes, storms, and sea level rise. Scientists predict between 1,800 to 4,000 square miles of land lost within the next 50 years. This is a number close to what's already been lost in the past 80 years. This rapid changing environment does not only affect economic activities, but also affects infrastructure like roads, power lines, and pipelines. It was with that in mind that one of our clients, an oil infrastructure company, wanted to ensure one of their major pipelines off of the coast of Louisiana, a 32-mile-long structure, was protected against all of these unknowns. They wanted to ensure that the land coverage on top of the pipeline was maintained. Whenever there's land coverage on top of the pipeline, that pipeline is protected from debris that comes with storms and other extremes. That protects the pipeline from breakage and leakage. Our client had gotten the green light to go ahead and install nature-based infrastructures and solutions in key areas of the pipeline, areas that had already shown to be losing land after time. The question was where to start, right? So then they had this question and they started the right way. Our client started by collecting data. They went into the field that they measured land coverage depth through many points along the pipeline. They did that in 2002 and in 2015, and they wanted to understand how the land coverage on top of the pipeline was behaving over time. However, when the data got to them, it looks like this. It pretty much looked like spreadsheets. All the numbers would jump before their eyes, and the decision makers were having a hard time making decisions. So that's where we came up. We were tasked with trying to make this data set make sense for decision making. So then I took my first step and I did this. I mapped the points in the data sets. However, as you can tell from this map and the pipeline scale of the data, you still can't tell anything. You can tell, in my mind, this is just one little step up from a spreadsheet. Of course, you can zoom in and try to see what the numbers are trying to tell you, but to me, that was not enough. That's when I was told that maybe this idea that I had, that one image was going to be able to communicate everything that I wanted, you're going to be able to look at the image and tell how the land coverage was behaving over time. Maybe that was impossible. Something was missing, and maybe what I had in my mind was impossible after all. But that's when it clicked to me. I understood that, yes, we were missing something, and what we were missing was an extra dimension. Using ArcGIS Pro 3D capabilities, I was able to map each data set as a vertical bar. Here, as you can see, the taller the bar, the deeper the depth of the land coverage in that certain area. I then used a yellow-red color ramp to emphasize the areas that needed most attention. Now, just mapping the data for 2002 wasn't enough. I needed to map also what was happening in 2015 and then compare how land coverage was behaving over time. However, just by looking at these two images side by side wasn't enough. Again, I had that image of, that one figure that would communicate the point of this data gathering really quickly. I started to then play with ArcGIS Pro swipe tool. I overlaid the data sets and swiped back and forth to try to understand what the data was trying to tell me. That was a step in the right direction of realizing how things were behaving, but I still wasn't there. Another point that was a challenge to me is that the points that were surveyed in 2002 were not the same ones that were surveyed in 2015. In other words, we were not comparing apples to apples. So what I had to do was I had to use ArcGIS Pro Interpolation Tools to get numbers for 2002 and 2015 for the same points along the entire extension of the pipeline. And then, by subtracting one from the other, I was able to get depth of cover change within the 7-year span of the data set. This is what I had in my mind. One image, all of the data points, everything that you need to know right here. I used the negative bars represent land loss in that part of the pipeline, and the positive bars represent land deposition. This exercise also allowed us to take a closer look at certain areas of concern and realize that areas of pipeline that crossed waterways like lakes and rivers were losing land much faster than other pipeline segments located on land. But we also realized that marsh areas or pipeline segments located in land were losing land at a smaller rate, but also having land eroded away. Using the depth of cover change from these 7 years combined with other metrics like presence of vegetation or presence of confluence waterways, we were able to get a total risk score for certain areas of the pipeline that were of largest concern. I then mapped them right here. Here, the taller the bar, the higher the risk that the pipeline will be exposed to breakage and leakage. This view allowed us to quickly understand where action needed to be taken first, where our decision makers needed to start funding restoration projects first. This also allowed us to compare and realize that our top at-risk priority water crossing, its score was almost twice as high as our top marsh area or land crossing. I then gathered all this information that I got from the 3D exercise and I summarized it in a good old 2D map. I think that's a really good way to just get your point across because after all, we're all used to looking at 2D maps, but it's important to show how you get to that point. After we gave this map with other conclusions to the decision makers, they were able to make a final decisions on where to fund restoration projects. Some of them are on the ground as we speak. Going from survey to action really depended on us as GIS analysts, as people that use the geodesign process, to go from this to this to this. So sometimes when you're faced with a challenge, people will tell you that maybe what you had in mind isn't possible, that maybe you can't do that after all. They say that something can't be mapped. If you're faced with that, don't believe it. In my mind, if it happens in the surface of the earth, it can be mapped. And if it can be mapped, it can be understood. When people understand your message, they take action. And a lot of times, these actions serve to improve lives of people like me, you, Mr. Melanson, and residents of the coast of Louisiana. Thank you.